Or do you want to come over on camera?
Sorry?
Do you want to come over just so you're on camera as well? A little bit? I can scooch out.
Hey.
Okay. Tēnā koutou katoa. My name's Mike King, and I'll be chairing this session. And I'll get things underway as quickly as I can. At the end, I think, Elizabeth, maybe you could fill in what our talk next week is going to be. Do you know? Yeah, great. Excellent. So stick around for that, a little teaser. And okay, so it's my pleasure to introduce Professor Yolanda van Heezik. Yolanda is from the Department of Zoology here at Otago, and she works in a range of areas in zoology relating to biodiversity and various other sort of value-laden concepts within that area. And a lot of her work deals with the human side of these sorts of things, what people think, how they value things, and how that affects these important biodiversity type values and other values. So today she's going to be talking about what makes a garden biodiverse, which is some work that she's done, which uses a method that is used in other aspects of bioethics as well. And so it's interesting to see how this method is operating in an environmental context, which is using 1,000 minds. So Yolanda, over to you.
Well, thank you very much, Mike. Kia ora koutou, everyone. I've had a long interest in gardens, actually, and it really started probably about 12 or 15 years ago when I was involved in a study together with Claire Freeman from Geography and Kath Dickinson, and we were documenting biodiversity in about 55 gardens across Dunedin. And so since then, I've just been really interested in the contribution that gardens can make to biodiversity across urban areas. And of course, there is a really wide variety of gardens. This is one that I pass every day on my way home up North Road. I guess you could call it a low maintenance garden. Even the plants and the Grecian urns are all dead. But at the other end of the spectrum, you've got gardens that look like this. So they are really well vegetated, but probably the most frequent type of garden across most of New Zealand cities looks something like this, where you've got quite a large patch of lawn, you've got some shrubs and maybe a tree or two. And most people tend to have a veggie garden out the back. And in some cases, there are hedges. Hedges often, well, they create quite a bit of vegetative volume. And this one's a little bit unusual because the verge out the front isn't just a plain grass verge, but it's actually got some native species there, including a tree. And even small houses on small properties can have gardens that are really well vegetated with native species. And this is an example of one. So in this image here, you can see aerial images from two suburbs in Dunedin, and I guess I've put this in to illustrate what impact vegetation can have on biodiversity generally. So these sections are pretty much the same size, and the houses are more or less the same size too, so that you can see that the suburb on the left it contributes a lot more vegetation to that suburb than the one up on the right. And in Dunedin, it's been calculated that the gardens or private gardens actually make up about 36% of the total area of urban Dunedin. And even in really big cities like London or Glasgow or Edinburgh, gardens contribute somewhere between about 22 and 27% of the total area. So cumulatively, gardens are actually the biggest green space across the city. They're much bigger than say any park and reserve network would be. And if you're a species like a bird and you're flying over the city, then you can imagine that that a suburb that has gardens like the ones on the left are going to be much more attractive in terms of places to find food or to find nesting places. And that's certainly reflected in all the bird counts that we've done in the past across the city, where you just get large numbers of species in suburbs that are well vegetated, and in particular you get large numbers of native species of birds. So for example, if you were out in South Dunedin or St Kilda, then only about 10% of the birds that you see would probably be native, whereas if you were in a nice leafy suburb like Murray Hill, then somewhere between about 25 and 35% of the birds that you see will be native. And there's also a trend for more of what they call medium density housing. And this particular image shows you what in fact this looks like. On the left, you've got a much older suburb, and on the right, you've got a newer residential development. So more residential developments like these are being built. And you can see here that although each house has a garden, it's rather small, and there are some green spaces that have trees planted, but there's no real structure to the vegetation in those green places, in those green spaces. There aren't any what we call, I guess, vertical layers of vegetation. And in New Zealand, you know, we've been hearing a lot about the housing crisis for some time. So there's a lot more of medium density developments being built, but also Kāinga Ora is tasked with replacing old state homes with new ones and building more. And so their goal is to deliver up to about 40,000 state homes that are affordable over the next 15 to 20 years. And in this image, you can actually see some of those homes that have been built, and you can see again that the garden's very small and that they're very simple in their vegetative structure. So we know that gardens like this really don't contribute much to urban biodiversity, and we don't really know why this particular garden is so stark. There'll be a whole range of mostly social factors that will contribute to that householder not planting. But when you see a lot of people's gardens and you think, it made us think, I guess, is there some way that we can incentivize householders to actually manage their gardens in such a way that they do make a better contribution to urban biodiversity? And that was I guess, the basis of this whole scheme that we've dreamt up. And when I talk about we, this was led by Phil Seddon, who's also in the zoology department, and myself. And there is a certification scheme for houses that has been developed, and it's hosted by the New Zealand Green Building Council. It's called Homestar. Some of you may be familiar with it, but this is a rating tool to assess the sustainability and the health and efficiency of homes across New Zealand. And it's even been included in the LIM report for Auckland homes. It's been around for about 12 years. So is it possible to come up with a certification scheme for gardens? And I've had a look on the internet looking for other certification schemes in other countries, and there don't seem to be that many. I found a few in some states in the US, and in Australia they've just launched something called Gardening Responsibly, but the Australian scheme is more about ensuring that people choose the right plants, so ones that aren't going to become invasive, for example. So what I want to cover now is just to quickly reiterate what is biodiversity and why we value it, how we measure it. And then I want to go through the development of the tool that we use to come up with a figure that represented biodiversity in gardens, and then show you some data from when we applied the tool. So what is biodiversity? Most people think of biodiversity just as number of species, and of course that's one component of biodiversity, but there's also genetic diversity, and that describes variations between subpopulations and subspecies. And then of course there's ecosystem diversity, and that's that sort of variety of different ecosystem types and the properties and the processes of those ecosystems. So biodiversity is a reasonably complicated concept. And why should we value it? Actually, there are quite a few reasons for valuing it, and I think one of the most fundamental ones is for its intrinsic value. So this is the page of the website on the Convention on Biological Diversity, and this was the first time, I guess, that the intrinsic value of biodiversity was recognised. So in their preamble, they actually start by saying that they're conscious of the intrinsic value of biological diversity, as well as all those other values such as educational, cultural, economic, scientific. So the Convention on Biological Diversity was was open for signatures at the Earth Summit, which was held in Rio de Janeiro back in 1992. And since then, I think that almost all the countries in the world, I think there are only 3 that haven't become signatories. And so all those countries that have become signatories have certain obligations under the CBD to protect their biodiversity and to value it for its intrinsic value as well as those other values. So this diagram tries to capture those values. So on the left, you've got the intrinsic value. On the right, you've got instrumental values, so, which of course are manifold and include things like food production, for example. And then in the middle, there's been a recent focus on these relational values, those that they kind of encapsulate those relationships we have with nature, so they can be related to well-being benefits, but also we may value nature or biodiversity for providing us with a sense of identity or a sense of place. And these kinds of values are seen through the ecosystem services that we benefit from. A lot of people are very unaware that we are getting these services often for free. People only perhaps become aware of them when, for some reason, we have to start paying for them. But you've got these instrumental services here, such as these are what are called provisioning. So those include things like food production and raw materials and medicinal resources. You've got the regulating services here, which can include things like pollination, air quality regulation, erosion regulation. You've got some supporting services here, which include photosynthesis, nutrient cycling, and soil formation. And here you've got those cultural services, and they reflect those relational values. So you've got things like the aesthetic values, spiritual and religious values, and mental and physical health, as well as recreation and ecotourism. And biodiversity underpins those ecosystem services. And there's a whole sort of field of ecology which is devoted to trying to understand the relationship between biodiversity and ecosystem functioning, and it's gone through a number of paradigms, and this one is probably the most recent one, where it acknowledges that there are these interrelationships between the environment and biodiversity and ecosystem functioning. So return to private gardens. So we know that they really potentially can support quite a lot of vegetation and other taxa that depend on that vegetation. So they have this instrumental value, they have relational value, and of course they have an intrinsic value. And we also know that gardens are quite important because they're the spaces where a lot of people can interact with nature on a sort of a day-to-day basis. They don't need to be traveling to national parks or other natural areas. And the research that we've done on older adults with limited mobility and also on children's independent movements show that gardens are really important for those groups that may not have the same ability to travel to natural spaces. So how do you measure biodiversity? This is something that ecologists have to grapple with. Most people think of diversity as being just the number of species, but in fact, there are two main components when ecologists try to measure it. And one of them is the number of species, which is referred to as species richness, but the other is the actual relative abundances of species in a community. So in this particular image here, you've got the same number of species in community 1 and community 2, there's 4, but in community 1, there are equal numbers of each of those species, whereas in community 2, it's completely dominated by species A. So, so that top community, community 1, would be considered to be a more diverse community. And if you think about a garden, then you can imagine if you had 2 gardens that had 5 or 6 species, but in one of them, one of those species, which might be, say, rhododendrons or roses, completely dominated, then that garden would be considered to be less diverse than another garden where the abundances of the different species were a bit more even. But of course, we do ascribe values to to individuals and species, and some of the more traditional ecological ways of trying to measure biodiversity in indices doesn't really capture those. And one of them is just that some individuals or species we might feel have more value than others, like a large tree that's supporting a whole lot of other taxa might, we would consider that to be more valuable than just a very small sapling of the same species. And the other thing that we value is whether species are native or not, or endemic. And that has come under criticism in the literature. So some social scientists have compared native plant advocacy to anti-immigrant nativism. They feel that perhaps the antipathy towards exotics is just a misguided prejudice against the foreign. They might question whether there are legitimate reasons to prefer native species over introduced species. And some of them also feel that that antipathy towards non-natives is kind of reflecting or reinforcing a kind of general xenophobia. And these issues do arise. I've encountered them when I've been publishing my papers, where particularly in other countries, I guess, where the proportion of exotic species isn't as high as it is in New Zealand. So in New Zealand, non-native species are just extremely common in gardens. In our study of those 55 gardens, we found that only 17% of the woody plant species were native. And in the bird counts that we've done across Dunedin, probably just over half of the species are native. But as I mentioned before, the actual numbers of individuals are much smaller. So somewhere between 10 and 35% of individuals are native. And so I guess conservation biologists in New Zealand really are concerned that specialist native species are lost in environments that have really high proportions of non-native species, and that results in a kind of a homogenized fauna which is dominated by these generalist non-native species. So that, and this is really at the expense of our natural heritage and our sense of identity and place. It's also been argued that native plant advocacy actually contributes to a process of botanical decolonization, which some consider to be an ethical directive in the Anthropocene. The other decision that we had to make was that we had to treat vegetation as a proxy for diversity in general. And that's because it takes a lot of time and effort to actually do ecological surveys of a space like a garden. If you really wanted to know how many invertebrates are there, you'd be sampling, sampling for probably the whole year. And also, bird counts would need to be made at regular intervals. So we wanted to develop a tool where you would just spend a couple of hours in someone's garden and you could come up with some kind of reliable indicator of its biodiversity value. And it's pretty safe to use vegetation as a proxy. There's quite a lot of evidence in the literature. In fact, there's a large amount of evidence that show that in fact, there is quite a tight relationship between the volume and the composition of the vegetation and the diversity of other taxa as well. And the other thing that you need to consider is the variety of land forms, like covers, and whether it's lawn or whether it's small shrubs or tall trees, as well as features like water features, rockeries, compost heaps, tall trees, because the research that we've done previously all show that these are quite strong predictors of general biodiversity. So our garden score, we wanted something that was simple, so that there was a simple relationship between the garden attributes and that our scores were related in a simple way to the garden attributes and the behavior of the owners or the householders. It had to be meaningful, it had to be correlative of garden biodiversity quality. It had to be attainable, so that was that we could come up with a figure that was just based on a fairly short visit. And ideally that it had to be repeatable, so that if different assessors came to the same garden, they'd come up with more or less the same score. And we wanted it to be very transparent, because ultimately, if we can get this to take off, we'd like owners, garden or householders to be able to use an app to actually figure out a value for their own garden based on the various components. So the first step was identifying a team of experts. We called it the TAG, the Technical Advisory Group, and this consisted of about 20 people across New Zealand. There was a whole combination of skills within that group. There was quite a few plant ecologists, landscape gardener, horticulturalists from councils. We had people from consultancies, people from different universities, and from Manaaki Whenua Land Care Research as well. And we asked them to come up with features that were indicative of biodiversity. And we used a modified Delphi process to do this. And this really just involves a technique where you have a group of experts and you respond to several rounds of questionnaires, and the responses are then aggregated and shared with the group after each iteration until you come up with something that the group is happy with. Right. So following this process, our group actually came up with over 180 different features. This was quite challenging to try to summarize, but what we tried to do was collapse and condense those into some high-level categories, and we came up with these 6 categories. Now, at this point, we removed 2 of the categories from the next step, and one of them was sustainability features. And these were because sustainability features were things like the amount of recycled material used, different types of food production, like veggies or fruit or berries, water management. And we didn't feel that we felt that even those were laudable activities, that they weren't really connected to native biodiversity, and we felt that we should pull it out of the score at that point, and if necessary we could create a kind of a separate score, a sustainability tick that might reflect those activities. And the other one was fostering connections, and this is a tricky one. It's really about the influence that each householder felt that they might have on, say, on other people to be doing biodiversity promoting activities, and also their commitment to biodiversity. So that may be whether they were part of an environmental group, or whether they contributed to sort of neighbourhood predator control. And we weren't quite sure how to deal with that, but we felt again that it was not quite on focus in terms of the actual biodiversity of the garden. So we pulled that out as well. No, so the 4 that we're left with, the first was habitat extent, and that was really a measure of the proportion of people's properties that were permeable. So that means that they weren't built on or paved. And here you've got 2 properties that are actually very similar in size, but you can see here that this has got a lot of structures built onto it, and it's got a paved area out the back. So the proportion of property left that is actually permeable, that something could grow in, is really small, say, compared to this one here. And yeah, paved driveways often contributes a lot to decreasing that habitat extent score. The second one was habitat quality, and this really relates to the vegetation structure. And in this particular, and some other features such as water features. And so these 2 sections again are more or less the same size, but you can see here that this one is just the top left one is very bare. It's just mostly grass. Maybe there's a little hedge at one end, whereas this is actually covered with vegetation. So the third category was habitat management, and this included quite a lot of information. For example, whether the householder had a free roaming cat, whether the householder was engaged in predator management, whether there was a compost heap, whether there was some kind of fauna enhancement activity, which could be bug hotels, it could be bird feeding, and also whether they were engaged in, whether they used pesticides and herbicides. But each of these were complicated. Like there isn't a simple yes that there isn't a simple way of saying this is good or this isn't good. In the case of compost heaps, they often harbour rodents like rats and mice. So it really depended on what kind of heap it was, whether it was covered. In the case of pesticides and herbicides, some of them are much more toxic and last for much longer than others. So we were trying to find out what kind of pesticides and herbicides they used. And in fact, if they use herbicides against environmental weeds, then that's a good thing. It's not a bad thing. So the fourth category was one that we called landscape connectivity or landscape context. And this is really based on the fact that the value of a single backyard for biodiversity is going to increase its neighbouring yards, also take up a pro-biodiversity effort. And that those surrounding features that might improve the connectivity could include street trees, and it could include proximity to a natural place. But you can see in this image that that house on the corner has got quite a lot of vegetation in its backyard, but it's pretty much the only one in that block, apart from another lone tree that does, and that there are verges there, but the verges aren't vegetated, or they're just covered in grass at least. Okay, so we have our 4 high-level categories, and now we needed to apply weightings to them. So at this point, one of the members of our group had heard about some software called 1,000 Minds, and when we went to investigate it, we were quite excited to learn that it was actually something that had been created by here at the University of Otago in the Department of Economics by Paul Hansen. And Paul was really helpful. He gave us access to the software, and he also spent some time showing us how best to use it. So thank you for that, Paul. So 1,000 Minds, for those who are less familiar with it, performs conjoint analyses. These are also known as discrete choice experiments. And you come up with weightings which are based on the collective understanding and intuition of a group of people. And they can be applied to a number of high-level attributes. And it does this by presenting a survey to a group of people, and they are required to choose the best option between a series of paired hypothetical alternatives. And each of those choices involves a trade-off. So, for example, in this case, you're making trade-offs in terms of choosing a car between fuel economy and price. And so each alternative is made up of this different combination of attributes, and through the choices that each of the survey participants make, then the software basically uncovers people's relative preferences, and it assigns what are called utilities or part utilities to the attributes, and that's economic speak for weightings. So presenting people with 2 options makes it easier for them to make these trade-offs, but you can imagine that for each high-level attribute that you've got a number of variations of that there can be a really huge number of potential trade-offs that people have to make. And this is where 1,000 Minds implements a pairwise comparison method, which they have called Paprika. Now, this is an acronym for potentially all pairwise rankings of all possible alternatives. And so what happens is that every time a person makes a selection or ranks a pair of alternatives, then Paprika identifies all the other pairs of hypothetical alternatives, and it eliminates the ones which are no longer relevant. And it does this by applying a logical property called transitivity. And so by implementing this process, the people who are filling out the survey aren't presented with hundreds of questions. Usually it's less than 25. So we created a survey, and we asked our technical advisory group to do the survey. 1,000 Minds is really widely used in a lot of different disciplines, particularly in the health sector, in terms of making decisions about sort of triage or disease classifications. In this case here, it's been used to actually explore preferred scenarios for lockdown. So with the high-level attributes being the type, the duration of the lockdown, the health consequences, the economic consequences. And also, this is an interesting project that was actually run by the DCC and won a prize last year for the Australasian Project of the Year, and it concerned the management of the shore between St Clair and St Kilda, and 1,000 Mines played a key role in this process. Because they wanted the community to be involved in this whole decision-making process. And by applying 1,000 Mines, they were asking them questions like this, for example, are you happy with which would you prefer out of the two? Low protection from erosion, but high access to the beach, or moderate protection from erosion, or a moderate access to the beach. So through this process, the people that engaged in it were able to understand some of the complexity of all of the I guess the issues involved, and also it was kind of a very transparent process, so they could see how these decisions were being made. So with our particular data set, we had our top, our 4 main attributes, our categories: habitat extent, quality, management, and landscape connectivity. And we created a survey that incorporated this information. So under habitat management here, this was a resident free-ranging cat. This was no management. This was native fauna enhancing activities. So that might be things like feeding birds, or having bug hotels, or having piles of rocks for lizards. This is anti-predator management, and this is a combination of both of those last two. And it was interesting because the output gives you lots of information, and one of the things it shows you are all of the hypothetical alternatives that were posed to the participants doing the survey, and how many people chose each alternative. So for some of the questions, the people doing the survey found them really easy, and then, say in this case, for example, everyone agreed that the second combination would be better. So they're choosing between a property that has quite extensive habitat permeable surface, but it doesn't have any vegetation on it at all. And on the right, you've got a more moderate, so there's less habitat available, but the vegetation, it's actually highly vegetated. So everyone chose the right in that particular case. But some of them were much trickier. So members of the tag did have some different views for a few of the questions. And for this particular trade-off, on the left, you've got high habitat quality, but a resident free-ranging cat, as opposed to moderate habitat quality, and you're actually doing some native fauna enhancement and predator control. So the group were split, and there were, I think, 3 people that just couldn't decide between both of them, and then you just indicate that it's equal. So 1,000 Mines tells you how many questions people took for the software to be able to come to a decision about what part worth utilities were ascribed to each of those main attributes. So here, one person actually only had to answer 8 questions, but the median number of questions was 18.5. So it wasn't an onerous number of questions to have to answer. And this is the actual weightings that were applied. So on the left, you've got median values for these 4 attributes. Here you've got the mean values with standard deviations. And so you can see that people actually ascribe the most value to habitat quality, and then followed by habitat extent, and then habitat management had the lowest weighting. And this can be expressed in a slightly different way that's maybe more intuitive, where, for example, habitat quality here was considered over the group to be 1.5 times more important than habitat extent. And there's quite a cool thing called a radar chart, which actually plots all of the values for each individual. So that and on top of that black line, the black dashed line, is the mean value. So you can actually identify individuals from the radar chart, and that is quite interesting, because then you can sort of relate that back to some extent to their own expertise. So, for example, the person that was an outlier in terms of considering that habitat management was extremely important, was someone who works for an environmental consultancy, and so all of his work is involved essentially in managing habitat. So at that point, we had the weightings for our high-level categories, but within the category of habitat quality, there was quite a large list of possible cover types that you could find in gardens, and which was this. And we needed to actually apply weightings across those 18 different habitat or land cover types. And so we asked the members of the group to imagine a standardized area of that particular habitat, and then to give it a biodiversity value that could be any number between 1 and 10. So we weren't asking them to rank them against each other. They just needed to give it a number, and then we took an average number across all of the our tag group, and then we normalized those values to come up with weightings. So the next step was to apply it, and we had a couple of summer students who were working on this project, and one of them was working in Dunedin and the other one in the Whakatūpu Basin. So, so the first thing that they had to do was, when they had someone who was keen to get their properties surveyed, was to calculate the permeable surface, that was that habitat extent category, and areas of land cover, and information on connectivity from just using an aerial image. And then they visited the householder. They administered the survey, which gave us all the information about management practices, sustainability, and those connections. And they also ground truthed all that information on land cover type and connectivity. They entered the values into a spreadsheet, and the spreadsheet was designed to come up with the scores. So we calculated the percentage for each garden, their score as a percentage of the maximum possible score. So we calculated for each of those categories, if everyone got the best possible score for every single element in the category, what would their maximum possible score would be. And then we applied the weightings, and we summed the biodiversity across to get the score. And so here we've got the raw score, for example, for each of these categories. This is the maximum possible score. This is the percentage of the maximum. And then we applied the weightings from the 1,000 Mines analysis to get a final score, which was summed to this value here. So we had come up with our garden biodiversity score. So in practice, what did it look like? So the two summer students managed to survey 46 gardens in the Whakatūpu Basin and 43 gardens in Dunedin, and this is the different property sizes. You can see that there was quite large properties involved, but the majority were less than a hectare in size. And this is the distribution of the garden scores. So we were quite happy with this distribution. It was a nice normal distribution. Some gardens had very low scores, as you can see, down somewhere between 10 and 15, and a small proportion had quite high scores, but this was as high as it got. So just looking at those low scoring gardens, the aerial image is a bit fuzzy here, but this is the property here. So this garden, I think, scored 10, and it was in the lowest shot over, which is I don't know if you're familiar with it, but it's quite a lot of houses that are crammed together pretty much. So this is the area of the house, and there's a driveway here, there was a shed, there was a few paved areas. This was a deck out the front, there was a hedge, and then there was just a little bit of lawn there. And so only 30% of this property was permeable, and 3/4 of that permeable surface was lawn. There was some bark chips, there was a bit of mud and clay, and then about 10% was covered in vegetables and flowers, and 10% were shrubs. They were all exotic. They had a free roaming cat as well, which didn't help their score, and they used quite a lot of Roundup, which also didn't help their score. This was the maximum scoring house, which is in Dunedin, and it got a score of 52. So in comparison, 75% of their property was permeable, and only 5% of that was lawn. And so they had these quite high proportions of shrubs, leaf litter, and vegetation at different heights. So we had different height categories, shrubs that were 2 to 5 meters high, trees that were higher than 5 meters. They didn't have a cat, they didn't use pesticides, they had compost heaps, they did native planting. So they got a really good score. And you might say, well, they had an advantage because they had a large property, which is true, but it's still possible to get a decent score with a smaller property. So this is a much smaller property that is the same size as that one in Lower Shotover, but the score was much bigger because a large proportion of the property was covered in vegetation of different heights. So if you look at the individual categories, these are the scores as a percentage of the maximum possible score that that person could have got in that category. So you can see that in habitat management, no one got more than 40% of the maximum. So there's quite a lot of scope for improvement, and there are a lot of things that people can do. So it's not difficult to improve that score. And here, habitat quality, again, that no one really got much more than 50% of the maximum score they could have got. And landscape connectivity was a bit messier. We gave all the people in our pilot study some feedback on their garden. So introducing a kind of a normative component, we actually ranked their garden against the other gardens that were in the study. So their garden is that little dark star. And so in this particular garden didn't score particularly well. And then the householder could have a look and see at which component they scored particularly badly in, which was habitat quality was not great. And they had on the back of that feedback some suggestions as to what they could do to improve that score if they really felt like it. So you're probably thinking that, and it's true, that large gardens have an advantage. And here we've plotted the property size against the score, and this is for all of them. So some were very large properties. If you just look at properties less than hectare, then you get this relationship here. And so we noted that if the properties were more than 500 square meters, then there was a fairly equal distribution of low and high scores, but for the properties under 500 meters, it does become quite difficult to get a good score. And so we felt that we had to accommodate that when we were turning the score into a star, a sort of a star rating. And we did that by calculating the quartiles for 3 different property size categories. So small were less than 500 meters squared, medium were somewhere between 5 and 1,000, and large properties were more than 1,000 meters. And so the idea was that, for example, you'd get 1 score if you had a garden biodiversity score, 1 star at least of less than 17.2. If it was a small property, but you'd have to get a score of 24 to get a single star. If it was a medium size, and you'd have to get 31 if it was a bigger property. So that's what we're sort of playing around with at the moment. All right, so I just wanted to finish by saying that in New Zealand, we are not very good at integrating biodiversity into our residential developments. And there are some quite inspirational examples from overseas. And this is one which is in Milan. Its name translates as vertical forest, and it's been around for nearly 10 years, I think, and has won prizes as being a project that really was described as blazing the trail for green high-rises. So in this case, the balconies are kind of staggered, and each one is supporting vegetation which provides privacy and shade, and also the potential for people to connect with nature. Currently, I'm involved in a research program, which is MB funded, and it's called People, Cities and Nature. There's a large team of us, but the sub-team that I'm in, which includes Claire Freeman and a researcher in the School of Architecture in Auckland called Mabrit Pedersen-Zari, we're we are particularly interested in how we can integrate more biodiversity in residential developments, looking at medium density developments. We want to come up with exemplars from international examples, and also to liaise with developers and landscape gardeners, all the professionals involved in developing these kind of residential areas, and understand more about the barriers and the motivations that actually affect whether biodiversity is even considered, and how well it is considered. So I'll stop there. Thank you very much, and I very much welcome questions.
Wonderful, thanks heaps, Yolanda. That was terrific. Okay, so questions. Can you raise your hand virtually if you have a question, and then yeah. Okay, Jenny.
Hi, Yolanda. Thanks for that. I was looking at my own score as I was listening to you give the talk about it to figure out where I ranked. So good job, me. But I was caught by the last thing, and this is probably something we can just discuss about in the department. But it's one of the things that I've been trying to initiate is like using our campus buildings as rooftop gardens. And it seems like there's a few ounces of hesitation to get that happening. Have you started having those conversations at all? I mean, and I've been talking to, I'll also say that the DCC approached me about doing stuff with rooftops, and I know Auckland is doing the rooftop gardens as well. So yeah, I'm just kind of curious about that.
So when you say rooftop gardens, are you talking about green roofs?
Not necessarily, just, popping a garden up on our roof, on our flat rooftop that's doing nothing except water.
It's not actually a conversation I've had with the university. I know that the psychology building has got well, it's a green roof, but it's called a brown roof because the plants are more brown than green, I guess. No, they do it. I think that's why I asked you whether were they green roofs, because I think a building usually has to be designed to support something like that. So
that was one of the concerns. Yeah,
it's difficult to kind of to retrofit a building to accommodate the extra weight. But I think that there is a lot of potential for adding structures, and say even on the front of the Mellor building, for example, it's got those wires to support ivy, and those kinds of things I think could be very easily incorporated into building design. So yeah, maybe we should have a kind of a collective group that approaches the university to
I'll try to catch up with you later at some point too, and let's keep talking about this, because I've got a lot of people excited to do something.
Yeah, a group of us did make a submission through our CEO Steve Willis regarding the hospital build, because there's a lot of evidence that biophilic design in hospitals can actually improve patient outcomes a lot as well. It's not just an aesthetic thing. So we put together some information a couple of years ago, actually. But I don't know, I'm a bit cynical about given all of it's going to be more expensive. So given all of the compromises that have been made so far with the hospital design, then I'm not confident.
That's a great idea though.
Yeah.
Oh, thanks.
Great. Okay, we've got Neil and then Elizabeth, and we'll try to wrap up sort of in about 5 to 7 minutes or so if we can. Yeah, great. Neil.
Thanks very much, Yolanda. I was also thinking about our garden at home and our cats. However, the question I have for you is really one of clarification. So early on, you showed what looked like a Venn diagram of intrinsic value on the left, instrumental value on the right, and an intersection between them, which you called relational value. Is that really what you intended? That relational value is an intersection of intrinsic value and instrumental value?
I have to, that requires a bit of thinking. I suppose I didn't create that diagram, but I think that.
So maybe I'm asking the wrong person.
Yeah, you probably, but I can kind of see why they did it the way that they did, because the kind of the values that we get from our relationship with nature often do intersect between our intrinsic values and instrumental value, especially when they concern our well-being. And so I think that there is a lot of overlap. You know, we can value nature for aesthetic purposes, but we're at the same time improving our well-being through that process of valuation. So I think that the intersection is actually quite a good representation.
Right. Okay. Fair enough. Thanks.
Elizabeth.
Thanks, Yolanda. I really, really enjoyed that. So my question is about the sort of trade-off. I don't think you posed this as a trade-off, but it seems to me that it is a bit of a trade-off between what we're really trying to do in New Zealand with housing at the moment, which is to increase density and provide as many, provide everyone with a safe and warm home, and the landscaping element of it, because you mentioned at the start about the percentage of city urban green space that is gardens, and it's much higher than I would have expected. But it just raises a question to me about where the obligation sits for creating these spaces, that perhaps it sits with developers, perhaps it sits with the government if it's a public housing project. But I wonder whether they would be equally well placed, or perhaps would be an argument for those resources to be put into more communal green spaces. So we perhaps trade off individual gardens or gardens tied to individual properties for more dense housing that reduces urban sprawl and more communal green space that is shared. So is there an argument for moving away from individual gardens and private property, to putting those resources into more communal spaces?
Yeah, no, that's a really good question, and I can see my my colleague Claire is probably itching to answer it herself. I'm going to say something brief, and then if Claire wants to add on to that, then please feel free. Yeah, absolutely. There is an argument for this trade-off, and even in terms of biodiversity values, there's been some research in other countries that's shown that, in fact, for general biodiversity values, it's better to actually have a large area, a large reserve, and smaller private gardens than to have all of these separate private gardens. So some species do much better by having that bigger area with less disturbance. But I guess the downside is, from the research that we've done, is that people do need these very nearby spaces, people that do have limited mobility and that can't get to bigger areas. So, but I think that from the point of view of town planning, and maybe I should hand it over to Claire from here, that she would certainly advocate that you can create these communal spaces. So go ahead, Claire.
No, I think you've done a very good job, Yolanda. You're absolutely right. That is the dilemma. And certainly when we have new compact housing, we do need to prioritise communal space. I think the issue is that, and what Yolanda has addressed, is that the majority, the 36% currently, is private gardens. And I think what Yolanda is doing is to try and get that 36%. So it's got better native and better biodiversity provision. But the two go hand in hand. So it's not one or the other, it's both together.
Okay, terrific. I had one sort of little thought, which was that I suppose a low score, Yolanda, is a little bit like a tick for your biodiversity potential in a way. So it was nice to see that you have some instructions for people, how they can go about improving it. I wondered though if rating gardens on their biodiversity potential was as simple though as sort of inverting the score that you've got that you gave them, or whether there was more to sort of assessing the biodiversity potential that different houses or properties have.
Right, I see what you mean. So it completely turned it around.
Yeah,
So
yeah.
No, well, yeah, I mean, that's certainly worth considering. I suppose we tried to address that in that feedback.
Yeah.
And ideally, I mean, the feedback was, I guess it was fairly simplistic, and what we would like to see is that people who are interested would have an app that they could enter various, enter data about their garden into, and that app would then tell them what they could do to make it better, and where they could go and get that information that would help them make it better. So ideally, we'd like to see it as a very sort of a hands-on process where people can be, looking at maybe focusing less on the score. But it would be, I still think it would be quite nice to have some kind of a public acknowledgement of your garden that you could put up next to your letterbox or something like that,
Yeah.
with your star rating, to show that that even though your garden, maybe your neighbours thinks that it looks really messy, it actually has some value because that messiness is supporting a whole lot of species.
Yeah, that's totally, and you wouldn't want someone to be advertising their property as especially desirable because it had massive biodiversity potential, because they'd completely decimated all of the
Yeah, exactly, right. Yes. Yeah, that's true.
Yeah, no, wonderful. Oh, look, thank you very much, Yolanda. That was a terrific talk, and it's wonderful to have these talks that remind people that bioethics is a broad discipline that covers value in a range of areas in relation to to life and health and living, and so much of these different values in bioethics are brought together in environmental philosophy, and it's wonderful to see how that can get applied in such a practical way to try and improve things. So thank you very much. That's terrific. And I would just turn now over to Elizabeth to perhaps tell us what is coming next week, maybe.
Yeah, thanks, Mike. We have next week a talk from Andrew Moore from the philosophy department. So there'll be a poster coming around this week that will have more information about the topic for the talk, which I don't have yet, but that is that's our speaker for next week.
Wonderful. That's excellent. Okay, well, thank you very much, and thank you again, Yolanda. It was terrific to have you as a presenter. Thank you.
Well, thank you all for listening.
Yeah, and thanks to collaborators as well.